we usually record because most of us would also love to like learn with us, and maybe they are busy with other things elsewhere. But then again, I mean, we usually just record and post them on our um, YouTube page. Thanks to Jen for that. So about WIDS, let me just take 1 minute to talk about WIDS. Women in Data Science Kenya is a regional uh, program that is part of Women in Data Science program in Stanford University. I joined the team in 2021, and we hosted a number of Women in Data Science conferences and datathons. So usually the goal is to just host some data science events uh, to promote data science here in Kenya, right? Um, and it's not only for women, it's for men as well, right? We believe that a healthy community has to include like both genders. So welcome everybody. This is just a session to empower everyone interested in data science. Today, we are going to have Diana. I'll let her introduce herself like really well. But Diana is one of the WITS ambassadors. Usually we organize those events with her, and she's also a data scientist at Roger. And then she'll be talking to us about relational databases and SQL. So over to you, Diana, and thank you very much.
Okay, thank you. So hopefully the online one is still working. So as Millicent has mentioned, my name is Diana Mutheu, also a WIDS ambassador, an associate data scientist at Roche. Roche is a pharmaceutical company. So being an associate, I majorly just help research scientists in research, right? So in the research of what pharmaceutical companies do. So for today, in terms of the relational databases, so as if you were there in the past session, this was actually supposed to happen sometime last month, but we had to reorganize it. And then again, also because I also had to change the content into a bit more beginner level. So there are some aspects we'll not cover, such as stored procedures, stored functions, what's the in-depth of normalization. Also, views will just touch at the top bit, but I've inserted a slide there on the topics that are also important on your day-to-day basis. So it will be just more of the basics, because again, looking at the registration, quite a number identified as beginners and as students. So I kind of had to bring it down. So I hope it won't be too basic, but anyway, just get 1, 2, 3 from it. So we'll look at the definitions, then a relational database, what that means, then SQL, and then finally close off with discussions. So basically, what are databases? So essentially, I think quite a number of you are already familiar with the term. So it's basically your container, or where you have your storage, where you store your data. And this could either be in terms of what we look at today, relational, and there's also non-relational databases. We'll see what the difference of this is. And to work with relational databases, we use structured query language. That's what we'll look at today. In case you've not yet been familiar with that. And then, so essentially we're starting at the top there, right? So your data source, you need to have your data source before you have your data product, whether it's a model or a visualization tool like Looker Data Studio and so on. So you need to start from the top where you're going to be storing your data, and then you go down through the process. So that's where we're going to be starting. And this symbol right here is the symbol for actually a structured database. So most of the time when you see that, just know it's the structured database. And also just to mention that I'm guessing quite a number, either I'll be using Workbench actually. I think it was the most basic. Well, it's similar to Oracle, but yeah, I think this is quite simple and basic just to get your way around it. So yeah, I'll be using Workbench throughout the period. All right, so we'll be starting with the data source. So this is what a relational database looks like, or a structured looks like. So this is an entity relationship diagram. So back to this slide on here, there's, if you've watched Dark Gently, the only statement you need to remember when you're remembering structured or is that everything is connected. So the everything is connected is what you see on this slide on here. So each table has a connection to the other, has a connection to the other, has a connection to the other. To display this, how the tables are connected, we use an AR diagram. So for example, you have your categories, you have maybe your equipment, or maybe you have a calendar on here, maybe when the equipment was loaded, or maybe when the equipment was restocked, and then probably the projects that need the equipment. For example, this is a project management database, for example. So you'd have this connection on here, and you can see there's one item at the top, that's the PK, standing for primary key. So this is what is used to actually create that relationship between the tables, and whatever lines you see here, they actually stand or represent the type of relationship from one component to another, in this case, one table to another. And that could be just on the basics aspect. So one-to-one relationships, or one-to-many relationship, or many-to-many relationship. So that this means just a quick example. So if you have a one-to-one relationship, for example, let's go into a hospital system, right? So a Dr. X, a Dr. X has an N number of patients. So one doctor, if I'm a cardiologist, or maybe what we call oncologist, maybe. So I'd have so many patients. So I'd have a patient, maybe, for example, database with patient personal information, and then one with doctors, and they link up through a one-to-many relationship, because one doctor could be seeing many patients. So that's one good example that I could give to look at the relationships in a database. Then I do love, I stopped sharing, right? This control thing, how do I get rid of it? I continue. Okay. Okay, so this is a cheat sheet for looking at how SQL works and the basics of SQL. So you do have, we look mostly at the data manipulation language, control language. I'll skip this, the transaction control, because again, it's not advanced, it's kind of intermediate, but again, starting. So commit, what a rollback is, what a save point is. So this I use to manage transactions. Definition languages to structure your table or a view. We'll see what a view is. Then group by, what an alias is. Functions, then you where. Functions can be two, either you create your own stored function or an inbuilt function, right? So same case with any other language, they have stored functions, or what you call, you create your own function, or an inbuilt function. So we'll try to look at that and see how that works. All right, so on here, you can see the data types, the SQL data types, and how they kind of look like. So you have your numerical, just like any other language. You have your strings. The definition just changes and what it carries, right? So if it's a blob, that's a large object. If it's a character, for example, which I think most people already know, for fixed and varying. So fixed character, you use the char, varchar. For if it's a varying, that's in length type, right? Your date types, your booleans, yes or no, the two versions, and then the user defined types that you can define your own data type, right? And then we'll also look into joins. So one important aspect also when it comes to working with tables or data, or even on your Python, even working with your data frames, more often than not, one table is not enough to give you information. So how do we combine to create that one table? So we use what we call joins. There are different types. So there's a self join, where it's the table within the table, and it normally creates a hierarchy. We have a right join, a full join. We have an inner join, a cross join. This one creates a Cartesian table. however you're seeing it being demonstrated on here, that's how it kind of works. So if it's a right join, all the components of the right table or what you define on the right side will be left, and only the similar tables, right, that are on the left side will be included in your result set. And then you have your left join, and basically, yeah, that's it. So as I mentioned, I won't go deep into inbuilt functions, but it's quite important to look into this, especially the ones that manipulate your date and time, data type. And then I also won't go so much into normalization and how to do this, but basically normalization just ensures that you misstep on the duplication of data, and simplify your queries. It's basically ensuring that each table in your database is a certain topic, right? So you don't have this whole huge item. Then stored procedures, what is the difference between stored procedures and stored functions? I won't go deep into this too. What are triggers, what are events, and table locking, right? Yeah, so these are the components that are missing. I did have them, but I had to calm down after seeing the and transactions, right? After seeing the registration. Then these are the resources that you could check out eventually after this. HackerRank is quite cool when you're practicing, and kind of, I think quite a number of interview questions come from HackerRank. So this I would highly recommend. And then your popular day-to-day W3 schools if you're a total beginner. That helps quite a lot. Right. Yeah, I guess. So now I will move on to my workbench. So my SQL work, I'll use the user interface. You could also use, when you download Workbench, it comes with the other items. All right, so let's look at how to first create or define your database, right? So I also have the codes on here, so just for the purpose of saving time. So you can create, and I also use this to teach. So create database bakery, for example. We want to create a database called bakery. So our tables will definitely, in this case, maybe we want to differentiate the sweet and the savory items. That's what our table is going to include, and then we populate the table and have the components. So let me just delete this. Let me drop this one so that we start from scratch. So running one line, I'll use the bolt sign with the 1. I think this is similar to also Oracle, because I know Oracle is a bit more popular. And at the bottom here, this is where you get your outputs, your action output, whether it's right or wrong, or an X. So it either worked or did not work, and the number of seconds it took to run. Then you use the database. Oh yeah, let me refresh here. So after you refresh, you can see the bakery database is back. And then for you to, because you do have quite a lot of schemas on here. So for you to actually run a query on there, you have to ensure that it's being used. So if you want to know it's being used, just double click on it. It highlights in terms of being bold, or you can run this code on here. So if I run that, then the database is being used. And this way now we can run queries. So let's say, for example, it's on bank, right? We are not using it. If I run this query, for example, why did it just run? Oh yeah. Oh no, it's created inside here. Okay. Let me see. Okay, let me go back to this. Yeah, so this way. So that's how that kind of works. So let me go back to this. On here. And then we try populating it. Oh no. Where did my code go to? Okay, yeah, that's fine. You can use this other one. Okay, so we could use this one. Let me drop this one. Yeah, so let me drop that one and then I will create it again. So if I run that, it should now show the created database customers. If I refresh, it should appear back again. And then running the use item, it becomes bold. And then now populating it, creating the tables within the database. So our first table will be called customer with the customer ID, defining the data type, it's an integer, and then assigning a constraint, which is not null. Same case to the second one, first name, last name, and then just specifying the variable character length as 55. So if it passes 55, then you definitely get an error, and then your constraint PK customer, which will be your primary key, and then passing in the name of that. So that will be this one. We're passing in the constraint of primary key to our first column. So if I run that, it has created. If I refresh that, you can see now we have the customer table. If I drop this, you can see that you have your columns specified on there. And then the next one, populating it again, we'll have to create table address for your other customers. So if you run this, run that, you do get your other items also populated inside there. So for example, your address here, the items you defined, your columns that have been populated on there. So same thing, the first thing, the syntax, this is how it looks like. The most important thing is your syntax, right? And never forget this comma, especially people coming from Python. They leave out that comma quite a lot. People from Java and the rest, they think they're fine. Then run that, another table added, and this one, run that again. You also have your table created. And then finally, our orders table. So far we have about 5 tables on here, right? Yes, or 4, yeah, 5 tables. So now that database is complete and we've populated it to the tables we want. So inserting or populating, there are 2 methods of doing this. Either you use the union all or your normal insert into whichever the table name, that's the syntax, and then define the values that you're inserting into, and then pass in the values keywords, and then the items to populate that, that section, right? So if I run this, it should complete, and the number of rows affected should be 2 because we are inserting 2 items into the database. Then into customer, into the table. If I run this, again, now we're inserting again 2 rows affected. Just always check your output. It will be your guide if there's actually anything that has been populated in or not. And then finally, your email address, run that, same thing. And if you defined or put a constraint as a primary key or not null, try out and have this as null. You'll see the kind of error you get. That's also a way of learning in terms of understanding the types of errors that are there in SQL. Then you also insert into your phone number, populate also your orders, run that, and you have all the tables now populated, right, with 2 rows inside, and now they have information. If you do want to alter, use the alter keyword to have items within your database, or maybe alter to add constraints, for example, you can use, this is how you kind of go about it. So alter table, call in your table name right after the table, then add constraints. These are basically keywords. Then call out the item that you want, the name that you want to give it, then foreign key assigned to customer ID, and then the references to customer ID. So if I run this, same thing to phone. If you need to add a constraint using the alter, this is how you'd go about it, and this is the syntax for that. Then we run that. Yeah, and that has been done. All right, so yeah, and then we have it. We have our items created within our table and within our database. All right, then the other method of doing that is using the union all. If you've worked with SQL before, you know the union all basically unites all, right? Vertically. So it will add items below, below, and below. So it does the same thing as your insert into using the value. So it can be either of this or the other one to add items inside there. So if I run this, for example, if I'm to, for example, let's drop the parts. Let me drop it using here. And then I run this. So, oh, yeah. And then I run this, create that, refresh. It should be back. Yeah, it's back. And then use it, double click, or just use the command. And then from here, if you run this whole section, it should basically do the same thing as using the insert, right? So if I run that, yeah, there we have it. Our table, our database parts is populated with this given item. So hopefully you can see that it basically does the exact same thing. Example here, select. Sure where it's not. Oh yeah, sorry, customer. Example, running that. You still have the same items inserted, right? So it basically does the same things to populate your given table. So union all or the insert item. Then your customer's view. Let's try and see how to create a view before we even go into other items. So a view is essentially a snapshot of your given database, right? So most of the times within your company or within your working area, you don't actually get to work with the actual database. Most of the times, especially if you're data scientist, engineer, scientist or analyst, you barely get to work with your given database. Why? Because of security purposes and also just avoiding to delete something that should not be deleted. So what you're usually given is an access to a certain view that is created from the actual database. So a view, as I mentioned, is a snapshot of your given database. So how do you create a view? So basically just the create statement or replace. So you add this just to replace in case it already exists with the new components. Then the name as is the alias, right? And then, no, sorry, not the alias, the keyword statement. And then as, so we now define what is going to create the view. You're selecting country, city, from address where the city, like London, right? So we're creating this from our customers database. So basically, well, what that means is where inside the address table, we'll use the address table where the city column, the city value column is Nairobi, then it will be used to populate our given view. So if I run that, then again, you refresh. You have your view created on there with the snapshots from your main data. Yeah, so most of the times you get to work with this. And then using your data admin, if you're one or mostly admins are the ones who do this. They give or define the access to the view depending on the person who's supposed to be accessing it. There are different types of views. I will not go into so much detail about that, but yeah, that's how a view looks like, the snapshot of your main table, right? And that's what most of the times you get to work with if you're analyzing something. All right, so the other thing we can look at, the other item we can look at is how to actually update. After we've looked at altering a table, let's look at actually updating something within your given database, right? So if you have certain information already stored in, how can you actually change whatever you have on there? So your keyword again is update. So update the phone number within this customer's database, then set the contacts or .mobile, for example, equals where this mobile phone is this. We're going to set this mobile phone for this person where the surname equals to Andrews, right? So that's the syntax of an update function. So let's look at ours and let's try and see if we can actually get this to change. Let me see, maybe using the first name. So, and that. So let's try change the first name first, right? For example, and we use the customer ID in this case. So if where we have the customer ID 1, John, we want it to come into a different name. So select all, update. For example, now you define what you want to update. Yes, table. Then this is basically just the name. So set. So we're going to set, we said the last name, the first, actually. First name equals to maybe X. Where, for example, the ID, I need the name of the ID. So basically where this customer ID equals to 1. So your customer ID equals to 1, right? Yeah, so if I run this should, let me save it. Oh yeah, customer ID equals to 1. Then if I run that, first name, how is the first name written? Okay. Underscore. That, and then that. And then let me rerun this. Let me run that again. First name, first. Like being in front here, you can't see anything. Okay, let's see now if it actually works. It's like I can't see my screen. Yeah, but yeah, the first name is now Alex. Oh, but yeah. So yes, and then now if you want to delete something, let's say for example, you want to delete an item, your command is delete, and then always put a where clause from when you use your delete just to narrow down to what is being deleted. So we want to delete customers ID from where it's 1, for example, now what we changed, for example, so if I run this, come on. So it's customer, how did they rate this? Customer ID. And if I run that, oh, oh, oh yeah, they're seeing it. These people in the room are not seeing them. Yeah, I'm not seeing. Right. Or ID. Like I can't see. Yeah, but yeah, that's how you delete. Wait, why didn't customers? The spelling. Custo. Which one is it? Customer.
Custom. The table is customer.
Oh yeah, it's customer. The database is customers. Oh yeah. Okay. Thank you. Oh yeah, it's a constraint key. Oh yes, but at least you've seen a constraint key error, right? Cannot delete or update if it's a foreign key too. So when you have relational databases, remember that connection. So you'll break a chain if you try to delete from one of the sequences, if one is actually a foreign key of another table. Okay, so tables are connected, right? So they're connected when one is the primary key of another. So it's usually more often than not, it's the foreign key of another one to connect them, right? So yeah, there. So now when you try to delete or update this error that you're getting here, down there, if you try to delete or update a parent row, it's not going to happen because you're going to be breaking the chain of connection. Yeah. I hope. I think you have to remove the connection, right? So that you're able to delete. You have to make it as the primary or the foreign key. Yeah, and then you're able to delete. Yeah, it should be like that. Oh man. But yeah, that's how you're supposed to delete an item, a raw item from a certain item, so that it's able to kind of the example that I had initially was for phone number. I think that one, but anyway, we can't finding that example again and trying to remember the structure of this table. But I think the other one was for the phone number. But yeah, I had an example, but this is basically how the syntax looks like. If you need to delete a certain item, just specify that, or a certain row. In this case, that's how you'd specify this. All right, so we've looked at updating, altering, selecting, deleting, though it didn't work. Should we do one that works? Creating a view. So the other one is, we could also look at a distinct statement, right? Since we have our parts database on here. So looking at a distinct statement basically is like you're unique for Python. So, or non-unique, depending whichever you're using. So let's use our parts. We've already let's select all from parts. So if I run that, you can see these are the items that we have within our parts database, within our parts table, our part table inside the parts database. Then if you want, okay, let's rerun this again. You can see PNAME, we have 2 screws, right? Because it's basically a database for selling parts, for example, that I found online. So you have 2 screws on here. So if you only want one unique item from there, so for SQL, this is what you use. So you select distinct and you have your distinct item. If you know other languages that's related to another language, it will be easier to kind of remember. And you can see your output for pname is just one screw, right? And you have a total of 5 rows. Initially, it was 6 rows returned. Then we could go further into selecting distinct. You can also use select distinct with a where phrase, right? So if I run this select distinct, JID, JName, JCT from project J. So this one is this table on here. So this project table on here. So we are selecting the items. So let's try and see how this looks like. From what's that project? Just to see how this looks like. And this is the table that we are trying to select the unique from with London, right? So if I run this, then it should return the distinct columns based on the where clause. And this is what I'd get in return, having London on here, the distinct JID, JName, and city. So if there are two, you can see when you still have a distinct despite these two being there, because this is part of the where clause, right? And still part of this point of the select statement, then it still gets returned because these two are still distinct. So it's already picked up that these two are not the same. Hopefully you've understood that. Right, so that's how you do select distinct. So the other thing is looking at aggregations. I do have my shop database on here, so I'll just go back and reuse this. So let's try and see how the table looks like. So if I run that, this is the sales one. We have our sales one table inside the database. Then the next thing is we have a question on here, find all records and all columns that took place in London store, not in December, but sales concluded by Bill or Frank for the amount higher than £50. So let's try and put all this into one statement, right? Because most of the time, these are the business questions that you have, and you have to select this data from the database. So the first aspect is we're selecting all the records, right? From sales one. So we select all the columns from sales one. We already know the table that we're using is sales one, where now we start putting in the conditions one by one. So the first thing is took place in London. I hope I didn't change that. Took place in London. Took place in London store, not in December, and month not equals to December. Same to, if you've seen this sign before, same thing, right? So not equal to same thing. Same thing in SQL, like that. And then adding, you know, the and operator just continues adding to the conditions that you have. Sales amount is greater than 50, and the salesperson is either Bill or the salesperson is Frank, right? So if you select all this is what we should get as our output. Yeah, so we get that the London store is that week 2, the days, because we selected all the columns, then the salesperson, Frank, Bill, and then the sales amount was supposed to be greater than £50. And what else was our condition? And not in the month of December, right? And this is what we get in return. And then the next item or the next question we have, for example, you're asked to find out how many sales took place each week in no particular order. So the moment you see no particular order, but most of the times you always have to use the order keyword, because I don't think anyone likes an ordered result. So this is what we'd get, right? Because you're being asked how many sales took place each week, basically in no particular order. So for each week, we're going to be selecting that week, the week column, then we pass in count. Count all is a mathematical function for this. And then from sales 1, and then we group by week, so that if it's week 1, we get the total, week 2, we get the total, basically just the group by function. An equivalent to this in Python is, I think, group by still. It's still group by. Yeah, so it's basically that. So week 2, we had a total sales of that 1. Week 5, 3. Week 1, we had a total sales of 2 sales in total. Right, and then on here we have now the ordering part. This is basically just adding the ordering keyword and showing you how this works. And it has 2 parts, the descending or the ascending order. By default, it's the ascending order. So find how many sales took place each week and present data by week in descending and then in ascending order, right? So if I have this, oh yeah, and this part, this is called an alias. If you remember the previous statement, we had the count, right? So if you want to rename that column, then you just have to put the as to create an alias. It's similar to importing pandas as XYZ, and then num sales. So this will be the new name of our column. So if I run this, if I run that, our default is ascending order based on the number of sales. So 2, 1, based on the week, right? Yeah, based on the week. So 1, 2, 3, and then if I undo this, then let's do that. If I run that, you can see how it kind of looks like in descending order. Right, so I basically think that was it for the most keywords. I do already have this database on here, so it's just using it and the joins aspect of it. So looking at how joins work, running that. Yeah, we're already using it. So let's try and now run the different kinds of joins, right? So let's select our tables just to see how we have 2 fruit baskets. So you have ID 1 to 5, so you have fruit, pear, apple, kiwi, orange, banana. And then our second basket has these items or elements. So pear again, apple, kiwi, melon, and peach, right? Then creating an inner join is basically combining the 2 sides of the table, if you remember the diagram, and having elements from both tables that are matching, right? And that's the pear, the apple, and the kiwi that are present in both the first and the second. Then basically an inner join, that was an inner join. If we go on to a left join, so the elements of the left table that we define will be fully left, and then the table that is combining, let's see how this looks like. This is what we'd get, right? So the matching items, remember the inner join returns up to 3, then the left join, so elements of this, whatever you define in your left, they'll be, all of them will get listed, that's for table 1, and then the elements for table 2, you'll only have the elements that are matching to this one, right? And then the others will be replaced with null values. So left and right join always return null values, but unless they're matching. And then the inner join returns a full set with no null values. So running this again, so the elements in the right, all of them are displayed, and then the elements that are not matching in the left are replaced with null, right? So we've removed banana, for example, from the other table, right? And that's the syntax. Then the outer join. So yeah, I put this here because quite a number of people coming from, I think Python has the full outer join. You confuse this quite a lot. It does not exist in here, but you can achieve a full outer join. You can achieve a full outer join in SQL by combining the by combining the left and the right join together into one. You can try that out and then you see how that one works out. So this one also, you can also add a where statement where you do have a join in case you do not want null values being returned, just to see which elements are not missing. For example, you are being asked what elements are missing in this table. So this is how you'd know. So right now we know that orange and banana are missing in the second table. Yeah, using the where clause. But you can try out to achieve a full outer join. So try that one out on your own. See, combine the left join and the right join. This way you'd have all the tables coming together. Unless there's another way. Anyone who knows any other way to achieve a full outer join? Yeah, and then before the subquery aspects, let's see a union so that you see how a union works and how the union worked in populating your table, right? So we're going to still use the same database that we created, then union all. So we're going to select table one ID, the fruits, these are the two columns as this, and then from this given table one basket, and then we're going to create a union with the second one. So the difference between this one and the joins is the fact that they attach each other horizontally. So this table comes at the bottom, right? And that's how you have now these two separate. With joins, you have them side by side. Then for union, let's see how this one comes in. Now, this one does not have duplicates, right? It removes the duplicated aspects. And you end up with a total of 8 rows in this case. So you can see kiwi is not appearing twice, like the union all. Apple is not appearing twice. It's basically just creating the union. And I hope now you've understood why the union all is also used to populate a database. Then finally, a subquery. So a subquery is basically where one query, so what we've been doing is running queries. As I mentioned, you query a database to get results. So where a subquery is essentially where the result of one query is used to define the next query. So for example, in most of the cases, you're usually querying from 2 tables at the same time. So let's go back to our customers database. This one was the one that was failing. Okay, so selecting first name. Let's say we want to see the first name and the last name of the person who has or who owns this phone number, right? So the phone number is a different table. The customer details, first name and last name, are in a different table. So to query them at the same time, we'll have to kind of create a subquery. So select first name, last name from your customer table, right? This is the name of the database, and then the customer table, and then C is our alias. And the importance of having an alias comes in, especially when you're working with subqueries quite a lot, in case you have similar names of your given tables that you're trying to query. So where the customer ID, so the customer ID in this case is the foreign key of customer, and as we saw in the failed attempt, and is the foreign key inside our second table. That's the phone number, right? So that's the connecting, that's the bridge between the two. So where the customer ID in, then now we start querying our second table, and subqueries are always embodied in brackets, where we select the phone number customer ID from customer's phone number. This one on here, now we are in this point, this part on here, right? Where, now we pass in the where clause, the person owns this number. So let's see who this person will be. I hope I did not change the name. Unknown phone number, PH. Phone number. Let me see. Let me select all the items of phone number and then we see. I think it's an issue. Select all from which database, which table was the issue? Phone number. Phone number. Yep. Show me what you have. So if I run this, phone number ID, that was the issue. So phone number ID. Phone number ID, phone number ID. All right, so if we run this, yeah, so the person who owns that phone number is Sam Smith. Yeah, and I guess that's it. With all the errors and backfiring and me not seeing my screen. I guess that's it, unless there's something else. I think the delete aspect. Yeah, I guess that's it. That was the most, I think these ones are the most important. If you're a scientist and you're trying to get anything from the database, this is enough for you. If you're a data admin, then you have to go deeper. But yeah, basically that's it. I don't think there's anything else I've left out, essentially. Yeah.
Questions?
No questions. Let's interact.
Yeah.
Yeah.
It's a comedy.
Yeah.
I think you can already brought
Yeah.
elaborate presentation. We need to highlight the areas that you shown us.